This video is a quick recap of solving systems of linear equations. So the first thing is, what is the purpose of solving a system of linear equations? And what you guys found out during your group work is that it is to solve for the point of intersection of two or more equations. And they don't always have to be linear, but we will be working with linear equations. So we're solving for the point of intersection. So there are three different ways that you could have a solution to a system of equations. And the first one is that you only have one solution, and that means the lines only intersect once. Another way, a possible solution would that there would be absolutely no solutions. This would be called an inconsistent system, and this occurs when you have parallel lines or when two lines have the same slope. And the third way of having a solution to a system of equations is having an infinite number of solutions. This is also known as a dependent system. If you look at the graph here, it looks like there's only one line, but there is one line on top of the other. This is where one line is just a multiple of the other line. So this should be a recap of what you guys learned back in algebra and algebra 2 with solving systems of equations. There are three different methods. The first method is called the equal values method, and this is when both equations are written in y equals or x equals form, and all you have to do is set the two equations equal to one another. So the example that I have here is y equals 3x minus 4 and y equals negative 2x plus 1. Since they're both since y equals both of these two lines, I can simply just set those two equations equal to one another and then combine like terms to solve for x. So I'm going to add 2x to both sides and I'm going to add 4 to both sides. I get 5x equals 5, and that means x must equal 1. But don't stop here. You're not done once you've solved for x. In this case, since I'm solving for a point of intersection, I also need the y value. So I'm going to substitute my 1 back into either one of these equations. You should get the same answer. And when I do that, excuse me, I get y equals negative 1. And then to write this as a coordinate, you get 1 comma negative 1. And so the first one is my x, the second one is my y. If I were to plug this into the second equation, I would get the same answer. The second method is called the substitution method, and this is when only one of the equations is written as y equals or x equals and the other is not. And then you just simply substitute the y equals or x equals equation into the other. So the example I have here is x plus 3y equals 11 and x equals negative 13 plus 5y. So since I have what x equals, I'm simply going to substitute it into the first equation. And then I'm going to combine like terms, and in this case I'm going to be solving for y first. It doesn't matter which one you solve for first. Combine like terms to get negative 13 plus 8y equals 11. Add the 13 to both sides. You get 8y equals 24, so that must mean y equals 3. Just remember, once you have solved for y, you're not done yet. I have to go back and substitute y into the equation and solve for x. So I get x equals negative 13 plus 5 times 3, and that's negative 13 plus 15, which equals 2. And so then my coordinate is 2 comma 3. A way of checking your answer to make sure it's right is to just plug it back into the other equation that you didn't use. So if I were to plug in 2 for x plus 3 times 3, I would get 11. And then the last method of solving for a system of equations is called the elimination method. You might also know it as the addition method. And this is when both equations are written in standard form, ax plus by equals c. What you want to do is eliminate a variable by multiplying one or both equations by a constant, and then you add the two equations together. And I want to emphasize the word add. You'd never subtract the equations. You always add. So if you do have to cancel something out, you might have to multiply by a negative number. The first example that I have is 3x plus 2y equals 48. And 9x minus 8y equals negative 24. So they're both written in standard form. What you want to do is look to see what you can eliminate, your x's or your y's. And in this case, I could either multiply the top equation by a negative 3 so that I would eliminate my x's, or I could multiply the top equation by a positive 4 so that I could eliminate my y's. I did the multiplying by the negative 3. It would pop up. And when I do that, I get negative 9x minus 6y equals a negative 144. And so now you'll see I multiplied the top equation by negative 3. You have to distribute that negative 3 to all three parts. So the 3x, the 2y, and the other side of the equal sign, the 48. So then I get the 9x minus 8y equals negative 24. That's from up above. And then negative 9x minus 6y equals negative 144. Now when I add these two equations together, the x's are going to cancel, and I get negative 14y equals negative 168. Divide both sides by negative 14, and you get y equals 12. So just remember, you're not done. You need to substitute that back into one of the equations to solve for your x value. When you do that, I get 3x plus 2 times 12 equals 48. I subtracted 24 from both sides, and then I divided by 3, and I got x equals 8. And so my coordinate, my point of intersection for these two lines is 8, 12. Example 2, I have another system of equations that is both equations are written in standard form. And so in this one, because 2 doesn't go into 5 and vice versa, and 4 doesn't go into 3, I have to multiply both equations to get it to a common multiple. And so what I did here was multiply the top equation by 5 and multiplied the second equation by negative 2 to eliminate my x's. You could have also multiplied the top by 3 and the bottom by 4 to eliminate the y's. So when I multiply the top by 5, I get 10x minus 20y equals negative 100. The bottom equation is negative 10x minus 6y equals 22. When I add the two equations together, I get negative 26y equals 78. Divide by negative 26, you get y equals 3. Just remember, you're not done. Substitute it back in. You'll get 2x minus 12 equals negative 20. If I add 12 to both sides, I get that 2x equals negative 8 and x equals negative 4. And then just remember, you can plug this back into the one of the equations or both equations just to make sure that it is the true point of intersection. Example 3, I'm going to do the same thing. I have to multiply the top by, I'm going to multiply the top by 6 and the bottom one by negative 4 to eliminate my x's. And then I get 24x plus 36y equals 72. In the second equation, I get negative 24x minus 36y equals negative 48. When I add these together, I get 0 equals 24. So what you want to look at, is this a true statement? Well, no, 0 doesn't equal 24. And so since that is not a true statement, that must mean that there are no solutions, and that means these two lines are parallel. So you always want to pay attention to if the statement is a true one. 0 equals 24, or do you get 5 equals 5, or 5 equals 7? So in this case, I got 0 equals 24, which is not true, which means there are no solutions. And then example 4, same thing here. I'm just going to multiply the top one by 2 so that I can eliminate my x's. You can eliminate your y's. You don't have to always eliminate the x's first. Multiply the top by 2, I get 10x minus 4y equals 8. My bottom equation stays at negative 10x plus 4y equals negative 8. When I add the two equations together, everything cancels out, so I get 0 equals 0. And since this is a true statement, that means that there are an infinite number of solutions, and that the bottom equation is just a multiple of the top equation, and so that it's a line on top of another line. So your assignment for Friday is going to do section 7.1. This is just a little bit of review from Algebra and Algebra 2. So the only problems I'm having you guys do from section 7.1 is 6, 8, 10, 22, 24, 26, 59, and 60. This is from the online text. If you are using the in-class text, then you're going to be going to page 723. So this will be due on Friday, December 5th. Have a good day.